Hello, today I'll be teaching you about transformation geometry. There's no catch to it this time, other than that we're not going to use any math because it's pretty simple for what it's worth. The math that you'll do is relatively simple when you're in grade school, and it usually is just rotating and by 90 degrees, shifting it over by a little bit, and changing the scale of it, which is relatively simple because the thing I'm more concerned about is stuff like using trigonometry and using sine and cosine functions for rotations and then scaling and then matrix stuff, but I have not even gotten to that. When it comes to elementary stuff, when it comes to elementary school transformation geometry, I have forgotten most of the math that comes with it simply because it's easy and anyone can do it. So what we're going to do instead is teach a theory. And of course you might be wondering to yourself, why do I care about learning transformation geometry? Why do I care about doing things with shapes, such as rotating them, reflecting them, translating them, which just is like let's show you real quick. So here's translation. It basically means moving side by side. Ignore the select thing. Translation is just moving it as is, nothing crazy there. Reflection is where you flip it. Wow, look at that. Rotation is, of course, depending on where you want to rotate it around, is like this. Whoa, yay, look at that. That's pretty cool, isn't it? And then, finally, we have scale, or dilation, which can honestly be something like this or this. That's kind of what dilation kind of does, but you won't have to worry too much about it for what it's worth. But why do you care about learning how to flip shapes? The more technical term is of course reflection, but why do we care about flipping shapes? Well, the simple answer is that if you don't learn how to flip shapes and you don't take this all the way to college, and if you're trying to become a mathematician, if you plan to do anything in programming or anything special of the sort, and some of those fields, the high level fields where you don't have to spend too much hard work, all you really need to do is use your brain to solve problems and do your job. Simply put, if you don't learn how to flip shapes, you'll be learning how to flip burgers, and I can assure you that's a worse fate than anything you could ever experience. So hopefully by now, and I mean as early as possible, you have decided on a career, because it will define your every moment from here on out, because you will be utterly screwed if you can't figure it out. But of course, I'm not here to teach you about how to get about life and stuff. I'm just here to teach you one skill that can help you along your life path. So here we are. When it comes to translating objects, aka just moving them about, well, it's fairly simple because you basically, if you wanted to shift this to the left by like 2 or 3 units, we're not trying to do any math, but 2 or 3 units is like just how much you would probably shift it in elementary school. You're not shifting it by like 1,000 or like a fraction or like a transcendental unit of distance. We're not worried about that. All we're worried about is moving it to the left or right by whatever distance we care about. Like we can move it 1 unit, we can move it 2 units, we can move it 3 units. It does not matter. But in order to move it, we don't do anything to it, to this shape. We don't rotate it, we don't like flip it, we don't like morph this shape into something else. This shape stays the same shape, basically. And we just kind of move it over. That's it. If we want to move it over to the left, we move it over to the left. And so on and so forth. Very, very basic stuff. Not much of a big deal, right? But of course, then we have rotation. Rotation is a bit of a funny thing because in elementary school, the only thing you're going to learn about is 90-degree rotation, which is very, very simple. you don't even need to do any math. All you need to do is substitution, like moving things around. Like, likely when you are given a point on, you know, each shape, say this point here is XY, right? Once you rotate it 90 degrees counterclockwise, because that's the more intuitive way, if you wanted to rotate it, the points on each point of this shape, typically you'll actually work with stuff like squares, which makes it more easy to understand. So why don't I show you that, actually. So let's go ahead and rotate around the origin, the center of the graph. That's what we call the center of the graph, the origin. It's really, really stupidly easy. And that's a bit off the screen, but we can go ahead and like move it a bit closer. And also this is incredibly not interesting if it's a near the perfect square. So let's go ahead and kind of shift that. So now we rotate it by 90 degrees. As you can see, it went from this thing here, this point became this point, that point, you know, over here became this point here, this point became that point, and this point became that point right here at the bottom right, you know. So basically the top right became the left, the top left, and the top left became the bottom left, and the bottom left became the bottom right, and the bottom right became the top right. It all kind of rotated around. And if this point here at the top right corner, the very edge here, is a point that doesn't really matter, and you know, on the x coordinate, the horizontal line here, it has some value that we don't really care about. We're just gonna call it like A, B, C, D, or E, F, G, H, I, J, K, L, O, P, Q, R, S, T, U, V, W, X, Y, Z. The X here, the X coordinate, the point where this edge is at, well, it seems to flip around, because like this is about the same distance here as it is here, you know, because it kind of rotated around. It's kind of staying still. And we could probably also do a little simple graph to kind of show you. Let's go ahead and make a really, really bad circle for what it's worth. Let's just make a really bad circle. Here we are. Let's change this color to, say, green. Now let's take the shape again. Move the spinning to the origin. And as you can see here, the topmost point, it stays effectively, it rotates around this point very, very similar, you know, completely smoothly around. And of course, we're only rotating by 90 degrees. That's all you really have to worry about in elementary school. When you get to like higher level stuff, you're gonna have to rotate in different angles, which is gonna be more fun for what it's worth. But they stay basically the same point away from the line, and also away from the origin, the center point. Again, we're gonna always be referring to as the origin from now on. And so if you rotate it 90 degrees, you might have noticed that it's a bit easy, because the distance from this point from the x coordinate is is the same when it's rotated 90 degrees, where the distance from the y coordinate that this is from, the y coordinate being the vertical line here, the one that goes up and down, is roughly the same. As such, if you rotate it 90 degrees, you can always be assured that when you do this, when you rotate it by 90 degrees from the top right corner with all the positive numbers, because usually that's where we deal with stuff, but in the normal thing, this is like other stuff that if you haven't learned graphs yet, I've honestly forgotten most of what I learned and when I learned it, other than like to memory, so sorry that I can't really tell you what exactly you'll be learning next to an exact T, but yes, that's basically what you do. Effectively, you just change places. The X position, or rather, the horizontal component on each point of this shape becomes where the point was distant from the, according to the y graph, to the y coordinates, to the y line. And the distance from the, basically, alright, let's just make this a bit more clearer. So basically, with this shape here, like, say I have a point here. The distance from here, like, right here, it is this far away. If you rotate it, it will be the same distance, effectively. Which, I'm just kind of doing it by head here, but, like, it's basically this is where it is on the X. This is where it's going to be after it rotates, which, given the lines I've constructed so far, I shall cease making more because I believe you can fill it in from here. Now, of course, you can keep rotating it by 180 degrees, which is 90 degrees, and another 90 degrees rotation. And generally, it just is this. Because, well, let's go ahead and take this. Let's rotate it real quick around the origin, per usual. Look at this. It seems to be reverse here. For a square, of course. You're always going to be dealing with squares. But, of course, we do have this as well. So let's go ahead and rotate this as well. This lightning shape. And it basically does the same thing. And it does as about expected. It kind of clips into the thing, but don't worry about it too much. But, yes, that is what that, all it does is just kind of turn it around. If there was a point here, let me just real quickly, if there was a point here and there was a point here, and we flipped it 80 degrees, this point would go all the way to here, effectively. Let's make a quick arrow here. This point would go here, a bit of a switch up, and this point would go here, basically. It's a 180 degree rotation. You're flipping it around the thing, kind of, but you're not actually flipping, you're not reflecting it. It's a completely different thing. But that is what that is, basically. Very, 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 very simple. Nothing to worry about too much there. And of course, finally, we just have effectively the same thing here, except, we are just doing the same thing, really. If we want to rotate it by 270 degrees, or by 90 degrees clockwise, turning it from here to here. Why don't I go ahead and visualize that for you by literally showing you that. If you rotate it by 90 degrees clockwise or 270 degrees counterclockwise, well, ta-da! Here it is. you rotate it by 90 degrees clockwise or 270 degrees counterclockwise. Either way, the same points that are on here get switched around here and are turned negative because they're on the negative side now. And then we have this here, and then we have that there. It's fairly simple stuff, really. And you might be wondering, but what happens if, say, I wanted to turn it around a certain point? What happens if, like, I wanted to rotate around a different point that's not the origin? Which is, you know, that's a good question. To which is very simple. What happens if you just want to rotate the shape about where it is? Like, you just want to rotate the shape itself, but don't want to change where it's like center point, its position really is on the graph. Well, that's simple. You just move the center point of the graph to the center of this shape, and then once you do that, you just have fun rotating it. That's it. That's basically what you do in math, except, you know, there's just a little bit of stuff. You take the difference of, like, the position on the, you know, from here, you know, you basically take the difference from here to here and here to here. Like, you take the difference here. The position of the point where you're trying to, you know, rotate it around, you just kind of adjust for the displacement, where the center of the graph changes, and then rotate about that point. And then you kind of just move the origin back to where it is, which is very basic and simple, right? Of course, you know, that's just the more complicated thing. Not really complicated. I mean, it's pretty simple. Like, if you wanted to rotate around this point, well then, ta-da, there you go. You know, now you have that point to rotate around. You just make that the center point, rotate around in respect to it. You know, you want to find the new center that you want to rotate around, and you can just do that, which is as simple as just, you know. Well, actually, the thing is that it's easier to rotate, if you're rotating an entire shape, you know, just the shape itself around the center point. But again, if you want to rotate the shape itself or like somewhere else, you just kind of want to move the origin, the center of the graph, to somewhere else. This isn't, you know, the actual center. You just are moving it in your head. It's imaginary. You're just making it in your head to make the rotations a bit more easier, especially when it comes to math, because doing all this weird math here with this, like here or wherever, is a pain for most mathematicians. So instead, we basically move this to the center. Basically, we move this to the center. So we subtract all the points on it by whatever it takes to get this to the center. So we move this here, rotate it, and then move it back to where it was, basically. Like, that's kind of what we do if we want to rotate it in place. But if we want to rotate it around the center, you know, just do the same thing. And if we wanted to rotate it around a different point, you want to move the shape so that way, you know, it's where it is in respect to the other center point. Like, say it's at the top right here, we wanted to move the shape here. Well, the shape seems to, you know, when we moved it, it seems to go here, somewhere here, when we try to move the entire graph of stuff. So, you know, we went from here to here. We kind of translated it, and then we went ahead, make this our center point, and then rotate it about. That's what it is. And then once we do that, we move it, you know, back to where we want it. Like, effectively back to here, but like the center point is somewhere there, and we can just rotate it about like so. And if we show you right here, like right here, let's move this here, keep that there. And you know, we moved this a bit further from the thing, from the graph here, and ignoring this for now, if we rotate it around this point, it seems to do like this thing, right? So let's move this back real quick. And if we do this here, it does the same thing. So basically, what we do in math is move things around so that way we don't have to deal with much math. That's all there is to it. And that's, you know, now that we've rotated around, it looks the same, except like it's just in a different place. You know, when we rotated this shape here around the center point, when we wanted to move it here, it went around like a little circle here. Like, it was going around, the point was always following inside and turning about. And when we rotated around, like the, you know, the different point where we wanted it to rotate around, the actual point where we wanted it to rotate about, not the actual center, but like a different point, it did the same thing. And that's what we did. And you're going to do that in math too. And it's not that complicated. It's really not that complicated. You're not doing like animations or anything like that. You're just rotating it like 90 degrees, which is very, very simple. And the next one is reflection, aka you know, turning this point, flipping it about, like right here, kind of. Let's just go ahead and like kind of do a perfect rotation, kind of perfect. I'm not trying to be, you know, I don't have like, I could use like an actual program to kind of show you, but like there's like a flip along the origin, the y-axis here, the vertical line. You know, that's just a horizontal that's a horizontal reflection, because we're reflecting all the points horizontally, because all the points here get flipped. Its height, its everything does not change too much. And if we wanted to do it again, but like over the z-axis here, or not z-axis, the x-axis, where we flip it horizontally, you can see that when it comes to, you know, doesn't matter which place it is, again, same thing really. So we went from, you know, starting here, our positions here. Don't worry about the variables too much. You'll get around to them eventually, I should probably mention. But the points kind of just flip around. These are the notations that we use to kind of just let you know that's how we do it. And this, as you could probably tell here, this is very, very different from, like, you know, because if we bring it back here, it's still the same. However, when you do this here, when you rotate it with just one flip, it doesn't start off where it should be before. Same goes for this. When you just flip it once. Rotating back to where it is, it's shaped and placed differently here. That's something to note. So what can you effectively learn from this? Well, basically, you need 2 flips to get back to like your same shape. Because if you reflect once, it's not really the same shape anymore. It's like the opposite. For all intents and purposes, it's not the same because it's not at the same points if you rotate it back to where it was. When you flip it once, it's like all the points are basically completely different. is gonna swap the, you just swap the, what was it called? Like the order, the magnitude, not the magnitude, not the order, the sign. The sign, yes, that's the sign. The sign is basically whether or not a number is positive or negative. Like say 1, 2, 3. These are what we'll call positive numbers. And then there's 0. And then -1. The negative there is the sign. And generally, all positive numbers also have a sign too. That's just hidden. We don't really care about it, and it's redundant. We generally presume all numbers are real, positive, like they exist. They're not negative. You're not taking away from it. By the way, for 0, it has both signs. There's like a plus, negative, plus, minus symbol. Why don't I go ahead and find that for you real quick? Yeah, there you go. That's the plus minus symbol. You just kind of place it like that. You write it like that. There is, in fact, a character for it. It's not on your keyboard. You're going to have to do some weird digging and stuff to really be able to write it. Or you can just look up on Google and copy and paste it. But yeah, that's basically it for reflections and transformations and stuff. Oh yeah, of course, you might be wondering, how do we flip this? How do we, like, flip this? Say I wanted to flip it, vertically along this line here. This, trying to shift it a bit. We don't really care much about the y-axis, or we're not trying to move the point. We're just moving effectively the axis itself, because that's all that really matters. Oh yeah, there is going to be some cursed stuff, such as flipping around. Let me just real quickly deselect all that. You might have to flip around. You might have to flip the shape around this line, which is a very interesting beast, to say the least. Or you might have to flip it around this line. Not exactly horizontal. Sometimes it could be whatever. So sometimes it can happen like that, basically. You might have to flip it around like different weird lines, but for all intents and purposes, all you have to worry about is the horizontal and vertical line when it comes to flipping. And, well, it's fairly simple. You basically kind of move both shapes kind of down and then kind of, you basically, again, you just kind of pretend this is the center point, or this is like where you want to flip. Because here's the thing. The only thing that matters is how far away each point is from the line you're trying to flip it over from. The same thing goes kind of for rotations, which I kind of showed you, but I'm not sure if I did a good enough job on that. But for this, it's a bit more easier to show, because, like, here's all these lines here, right? And now, basically, I want to do the same thing. I want all these points here to effectively go upside down, basically. The same point here is where this point is going to be. The same point here is where that's going to be. And, why don't we go ahead and, like, show them. It's a bit rough. I didn't really trace it out properly, but that's basically where the points should be. And flipping it around like that, that's basically it. And, we have this line here that's pretty distant, and this line there that's pretty distant compared to, like, the other stuff. That's basically what we do for, reflections. We just kind of find the distance from each point on the shape is from the line where we're reflecting it over, and then just kind of, doing that again, but whatever. I'm pretty sure you know how to find differences between points. If you haven't, it means you skipped the grade, you haven't been paying attention in class, or some other issues, which I which I can't really help you with. Now, the last one is dilation. Again, it really doesn't matter. A square is more easier to visualize, but a complicated shape like this is also just something. Dilation is basically just kind of like scaling it down, scaling it down or scaling it up by an arbitrary amount. It's not necessarily specific. Like, I can go ahead and, like, do this. It's just basically stretching, shrinking, growing, basically more like kind of distorting the shape. And, there's not much I could say about how these distortions, these dilations work effectively, because sometimes they can just shrink in place, basically. I'm not sure how to, like, put it. Like, here's, like, say you wanted to shrink it here. That actually, yeah, no, I completely forgot I had that button there. So if you wanted to, like, morph it around this point, well, the best way to do it is basically make that point there the center point of this shape, the artificial origin, the fake origin, the imaginary point that we want to, like, distort it around. But sometimes, like, we do stuff by distorting it by effectively, going about it near the center, basically. So it's not too complicated. Like, say, like, we wanted to have everything. We wanted to, like, decrease everything by, like, half a distance, or, decrease. So, like, where 2 becomes 1. We're basically dividing the shapes, all their coordinates, by 2. That's what we basically did to the shape. And, what happens if we wanted to stretch the shape by, like, a little bit? We want to stretch the shape by double it, or just by 1 unit, or whatever. We just can kind of do that, basically. Let me just, where this point is, got it. Right about here is about double the coordinates. Like, this is, like, 1 is right here, 2 is right here, and then, that's basically what we kind of do. If the shape is, like, near the center, we can do more crazy stuff with it and, rotate about it kind of more easily and, like, distort and stuff. But when it comes to dilation, we're not trying to reflect it, flip it around, mirror it. We're not trying to translate it. It just kind of happens sometimes. We're not trying to rotate it either. It just kind of happens. But the main thing is that it kind of morphs into, like, different sizes. Sometimes its side becomes longer. Sometimes its height becomes longer. Its length, width, all that stuff. It's very, very simple. And I have basically talked without any math regarding this, but when it comes to any transformation you can do onto a shape, all you have to do is, well, find out where you want to flip it around. You want to flip it, like, on this line, if you want to flip it around this line, or, if you want to rotate around this point here, the center here. The graph here is just kind of just following the weird point that we want to care about, if whatnot. And translating, you don't really need to focus too much about. Well, actually, no. When it comes to translation, you can basically think of it as this. You move the center, and then the shape moves along with it. Because what's it's basically, how this stuff here, right here, and then we go ahead and move it. It's basically you move the entire thing about, right? And that's where the shape would be after you translate it to this point here. Like, you wanted to move it, this much and this much. You wanted to move it by this much to the left and this much downward. This much to the in respect to the y-axis, and this much in respect to the x-axis. How much you wanted to move it to the left and bottom. You can also do the same with, moving it to the right a little bit. Again, same principle. You move this entire thing, and ta-da, that's just how much, it didn't really move much, because we didn't move, like, the point that we wanted it to move about too much. But generally, when it comes to any type of transformation, it's basically making an imaginary center point where you can do stuff with a shape that you already know how to do stuff with, and then just kind of moving it about. And, if you were to, like, move the point to the center and, do all that, again, same things kind of apply. You just kind of make it easier for yourself. You don't need to think about, like, alright, so you want to, like, subtract this from that, and then do this weird, and then you have to take into consideration that, like, the distance here is not the same as this, and then, you can't really just minus xz swap positions. I need to do all these weird math. No, you don't. I slept through most of my elementary school class. This is how, when it comes to math, the thing that people tend to focus too much on are the numbers. The numbers are completely stupid. They don't matter, and you won't even be using numbers by the time you get in the, like, higher level, like, you start drawing pictures. And you're, like, using stuff like category theory, right? There's no numbers involved. You are literally just that's really it. Like, you don't need to use numbers for, like, math and stuff. Numbers are just the stuff that help you introduce it. But, like, if you still think that math is still about numbers instead of just, like, about logic and stuff, that's actually why the teachers, like, teach you about math, by the way. They're not actually asking you how to, like, numbers are important, though. Numbers are fairly important for calculations and stuff, and you will be using them in real life and everything of the sort, but what they are not testing is your ability to, like, do addition or multiplication. It's about how you understand things. It's about understanding relations. It's about understanding stuff that you can use numbers on. You're not learning how to use numbers. You've already learned how to use most of everything that you will ever learn how to use numbers on. You already learned how to add things. You know how to subtract things. You know how to multiply things. You know how to divide things. And those 4 basic operations are, like, the only thing you really need to manipulate numbers. Of course, you will definitely get into, like, imaginary numbers, quaternions, matrices, and they're, like, non-associative addition. You don't need to worry about any of this, by the way. You'll get to it when you get to it. But, like, when it comes to math, numbers do not matter. You are literally, like, it does not matter. You can give me any number on this entire thing. You can give me, like, let's just make a random stupid thing. Like, here we have this, we have, like, 2, 5 on this point here. It really does not matter. It's arbitrary. It's could literally be anything. I could not care less about. Right? So then we have all this crap here. And so what points, what are the 4 points that this shape will end up if I do this? Like, what are the 4 points that this thing is going to end up at? Without, like, really having to think about it, without having to, like, rotate it. When you're in grade school, you can just draw it. You don't really have to worry about it. But say that this point is A, B, C, D, And this is A, B, C. Let's just go ahead and B, C, D. Where do these points go? Where are these points gonna go to? What can I do here? Well, if we're just rotating it about the center point here, right here, we're not too worried about anything too crazy here. All right, we're not trying to rotate about a different point from here. I know that this point will be equally distant when it comes to this, you know, these distances are going to be the same. And when it comes to this, when it comes to, you know, how far away this point is from this here, let's go ahead and like kind of show you here. It'll be the same as this right here. So the only thing that kind of flips is that A kind of becomes -5 because like that's the distance from the Y thing. And then when it comes to distance from, you know, how far it is from everything of the sort, let's just go ahead and move this down because it's kind of a bad visualization here. Let's just, yeah, somewhere here, kind of. You know, it's a bit weird, you know, I kind of clipped it a bit weirdly, but don't think about it hardly too much. You know, this is, once we move it to this point here, right about here, well, you know, again, we're only the Y distance from that point, you will have noticed, is just 2. And we can basically do that for every shape, you know. The C point is just 2 here. And then this shape there at the other point at B becomes 7, and then D becomes 7. And when it comes to the other stuff, well, you just do the same thing. B becomes -5 because we're keeping the distance from the x-axis. It becomes the distance from the y-axis, and that is where it is on the, you know, from the origin on the negative part of the x-axis. And same thing basically applies here. And if we were to draw all of that, and if we were to like do all sorts of stuff here, I know that this is going to be like this. The first point is going to be here, second point here, 2, 1, nothing too crazy, but it is still like the same kind of, it's like just shorter right here, kind of, not too distant. And you know, and then we have 7, 5. You know, we are a bit further from all that stuff. 2, 5, 7, 5. We want it to be like pretty damn far away for what it's worth. It's like, let's see, about my finger's length, so it's about like right here, and that's all I really need to construct my rectangle. This is about where it's going to be if I rotate it. I don't need to be too specific, but if you want the specificness, you can go ahead and do it on your own time. That's going to be a problem I'll assign to you as homework. Oh yeah, by the way, I hate homework, but here's the thing. If you want to learn stuff, you also got to try it out on your own time and figure it out on your own time. And actually delegate it to your memory. Yeah, but I hate homework because I've instantly mastered it, and it's something that's going to have to be something that you're going to have to learn to do as well, because it's something that they're going to test you on. But personally, if you guys hate homework like I do what I do and just do it in class, because I don't care too much about it. When it comes to like grade school and high school and stuff, your grades don't really matter that much. Except for kind of high school, but even then, doesn't really matter. You kind of need you just really need a decent GPA to graduate well. And even in college, like the only GPA you really need is just the stuff that you need to like graduate and like get your degree, really well. Like You don't really need a really decent grade. The only thing jobs care about is that sheet of paper. Like, you can go ahead and do anything you want with that sheet of paper, such as uh, rotating it, reflecting it, transforming it, or diluting it. But it's the paper. The paper does not matter, or not. The paper does matter, but like it's the only thing that matters. Your grades, how you get to the paper, does not matter. So long as you have the paper, you can be hired. And if you're able to get that paper, congratulations. You have a fairly good chance of escaping having, instead of flipping burgers, you just flip shapes on a computer by multiplying matrices and using trigonometric functions and stuff, because this is the very, very fundamentals of that. However, you might end up having to flip burgers anyway if you do not make connections in college. Ask around for help. Ask your teachers. If you have, if you have teachers, they can help you find the job. They have the expertise. They've been through the same stuff. That's why they know everything that you have. That's why they're teaching it, and they probably have been through the same experience, but they ended up being a teacher because that just happens to be, the only place that would fucking hire them, aside from getting like a teaching degree, because they kind of tutored around, and they just ended up being very good at teaching because they got some connections, they made some friends, and there's the school that's looking for this teacher here, and there you go. That's how your jobs work. You don't really get in through a lot of qualifications and stuff. You basically get in through jobs, through relationships, your connections to other people, and although that's not covered in math, well, if you can't do that, there was probably I kind of wasted like 40 minutes of your entire life basically teaching you something that you're never gonna really use because you're gonna end up flipping burgers, or maybe you're not really that interested in math anyway. You're gonna choose a different degree, or you might just end up teaching math, or you just, I don't know, whatever, or some hobby project of yours. You can always do programming and use this knowledge in your own time without actually making any money. But don't be like me, kids. All right, just don't be like me. If I've been alive way more longer than I would like to, because goddamn, I would much be rather flipping these stupid shapes than any freaking burgers, flipping food around in a cooking pot, and dealing with unruly workers who basically are so slow that they don't do anything, and you basically have to carry them that you've throughout your entire fucking life. Oh hey, can you do this for me? Can you do this for me? What have you done for me, you little prick? How about you back your ass up and actually do some goddamn work? But of course, if I say something like that, I'm the one who gets fired because I'm the one who's acting out rather than doing my job. But of course, that's why I quit and I'm going homeless in like a few months. Don't be like me, kids. Don't be like me, kids. Learn how to flip shapes. Learn how to rotate shapes. Learn how to slide shapes to the left, slide them to the right. And maybe one day you won't have to worry about flipping burgers, and you make lots of friends. I don't care if you're the silent kid in class. I don't care if you suck at making friends. You gotta make friends. And you don't have to make genuine friends you make a connection with. They can be fake friends. All you have to do is just get along with them and be able to make use of them. Unfortunately, that's just how the world works. And if you can't stomach the heart to do so, then you're going to have to accept that you're probably going to end up like me, and you're going to have to live a really, really harsh life. And if you like this life advice, aside from all the dumb crap that I just taught, feel free to like my video and subscribe, because I need the numbers pretty freaking urgently, because I just left my job, because I was going freaking jack shit insane from my freaking job. So if you wouldn't mind trying to support me a little bit by showing YouTube that I can be successful, I'm not just some stupid one-hit wonder, which is only being sustained and only getting pretty views from a very few videos that make me very few money in terms of the grand scheme of things. If you could like and subscribe, those things are free, but it will give me money in the long run. So feel free to do so if you enjoyed my content. Please fucking do. And have a good day, guys.